Hey there, today we're going to take a look at how to write integration tests against a GraphQL server in Nest.js. Now, I already have a video about writing integration tests against an HTTP server using supertest in Nest.js. So if you'd like to see that, I'll leave a link in the description. Otherwise, we can jump right in. And of course, I'll leave a link to this repository in the description so you can follow along with me as we start to build these integration tests. So I'm starting this project off based off of a Nest.js starter repository that I will leave a link to in the description. This is a repository that I use to start off my projects and includes database layer access with MongoDB and JWT authentication, as well as a GraphQL server out of the box, already all set up and ready to go. As you can see here, we've already set up the server. I have previous videos that go into depth of how to build the foundation of this starter project, including the MongoDB database, JWT authentication, and setting up a GraphQL server in Nest.js. So if you're interested in those topics, please be sure to check out the description where I'll leave links to those videos. So in our application, we want to go ahead and test out this GraphQL resolver or users resolver. We want to make sure that we can create a new user, that the user shows up in the database, and we get the expected response back. Secondly, we want to make sure that we can actually retrieve a user using the GraphQL endpoint here, and that we get the expected user back when we use the expected arguments. So after you've gone ahead and cloned the GitHub repository, which I'll include in the description, of course, make sure that you install the dependencies required to run this project. So we're using pnpm as our package manager. So make sure you run pnpm install or whatever package manager you'd like to use to make sure that we get all of our dependencies that we need. And so let's go ahead and create a new folder in the users directory called test. And this is where we're going to keep all of our integration tests. And so it's inside this folder. Let's go ahead and create a new folder called integration. To keep things organized, we could keep unit tests and integration tests in the same directory, as well as any supporting files like stubs that we're going to use. So for now in integration, let's start off by creating a create user.integration spec.ts. So I'd like to create a new test file for each route in this resolver that we're actually testing. This is just personal preference to keep our test files very organized and focused. So we can go ahead and create a describe block here called create user, because this is the operation that we are going to be testing on our GraphQL server. Now, there's a number of things that we want to do whenever we are executing integration tests in our application. We need to bootstrap the Nest.js app, insert a dummy user so that we can have authentication work with this user. And lastly, we want to be able to close the app after we're finished our tests. Now, we want to create a common class that we can utilize in all of our tests to do this setup work for us. So let's go ahead and do just that. In our root directory here, we can create a base test folder. And inside of that test folder, let's create a new class called integration test manager.ts. And so this is going to be a simple class that our test files can instantiate and use to manage all of their test setup and get access to the Nest.js application in case we need to use the database or get a JWT authentication token. So inside of this class, we're going to create a new function called before all. Now, before all will return a void promise, and really what we want to do here is all the setup work required in our integration test. So the first thing we need to do, of course, is actually create the app that we're going to be testing. So we can call test, and we import test up above from Nest.js/testing. So we can call it test.createTestingModule, where we take a imports array and we pass in our root app module. Our root app module is what actually contains the GraphQL server and is the real app.module that we use when we're bootstrapping our Nest.js application. We are just instantiating this app outside of the typical approach where we start it in our main.ts. Instead, we're doing this in our integration test manager. So we have this app.module supplied, and then we can call .compile to compile this testing module. Now we need to actually create this application here and assign it to a class variable so that we can use it later on in our tests. So let's create a new variable called app, and this is going to be of type inest application. And then we can assign this.app is equal to module ref dot create nest application. So now this.app will be the application, and we can use that later on in our tests. Next, we're going to call this.app.use, and we're going to call cookie parser. So our application is using cookie JWT authentication to authenticate users in our GraphQL server, and we can see that here that we're using an auth guard, which takes advantage of this authentication. In order to test this out properly, we need to actually use the cookie parser middleware, just like we do in our main.ts, where we call app.use cookie parser so that we can actually parse incoming cookies. We need to do the same thing when we instantiate this Nest.js testing module, because it will not do it by default. Next, in our import, make sure you change the import for cookie parser as import star as cookie parser. And then lastly, we can call await this.app.init to initialize our Nest.js application. So we're now going to need to get a handle to our HTTP server. And this is so that we can supply the HTTP server to super test. When we actually use our integration tests, we need to supply the underlying HTTP server. So let's create a public HTTP server up top as another variable, and we'll type it as any. We'll go ahead and assign this.http server, and it'll be equal to. And so now that we've set the HTTP server, there's a few more things we want to do in our setup. We want to actually get access to the auth service in our application so that we can set a JWT access token that we can use later on in our tests. So let's go ahead and do just that. We will create a new const called auth service, and we're going to call this.app.get and pass in the auth service, which our application uses to authenticate users. Now that we have the auth service, we also need to get access to the underlying database connection in our application. So we do have a database service already configured. If we go ahead and look at our database service, we have a way to return our DB handle that we're using Mongoose under the hood. Furthermore, if we take a look at our database module, we can see how we are returning our MongoDB connection URI. We can see that we're using the config service to check if the node environment is equal to a test. And in the case when Jest is running our integration tests, this will be true. So we will return a MongoDB test connection URI, so that the database we're using when we create these integration tests will be completely different than the database that we use when we are developing locally, so that we do not corrupt any data. So we can see if we're not running the tests, we will use the MongoDB URI. So make sure that in your application you have a .m file. So let's go ahead and create a .m file at the root of our directory, which the config service will use to read in environment variables. And let's go ahead and paste in the relevant environment variables that we need to run this application. In this case, we will need a port that the HTTP server will be listening on port 3000. And here are our two MongoDB URIs. You can see we're pointing at localhost 27017. Our testing connection URI is /test, and our development one is GraphQL end-to-end. Lastly, we have two JWT environment variables here, one for the secret and an expiration, how long that JWT is valid for. So make sure you supply these environment variables so that your application works correctly. And then we can go back into our integration test manager. And now we want to actually declare another variable, and this will be the actual connection from Mongoose, the actual database connection. And to get access to this, we can set it equal to module ref dot get, and we are going to pull the database service. And you can pass in the database service here. You may need to actually import it manually, so let's go ahead and do that. We'll import the database service from database and database service here. And so once we have the database service, we can call get DB handle, and now we have the connection to the database server. And so now that we have a connection to the database server, we actually want to make sure that when this application starts up in testing mode and we are running our integration tests, that we always have a test user in that database so that we can use that user as the testing user and correctly authenticate with our backend using a JWT access token for that test user. So how do we ensure that we always have a test user in this database when we start the test? We can take advantage of just setup and teardown hooks in our package.json. So let's go ahead and create a setup file. In our test root directory, let's create a new file called setup.ts, and this will be a default function that we export here. It will be of type promise void. And so let's go ahead and in this function, what we want to do is create a new module ref. So we will do the same thing we've already done. We will call await test.create testing module. We will import the root app module and compile this application so we have all of the services that we will need. We will call module ref.create nest application and finally call await app.init to actually start our app. Now what we want to do is get a handle to the user service. So we'll call module ref.get. We will pass in the user service. And now we're going to call await user service.create user because we want to create a testing user in our database. So we need actually a test user that we can insert. So let's go back to our users directory in our test folder. I'm going to create another folder here called stubs. And stubs will contain any dummy data we're going to use in our tests. So we can create a user.stub file here. And let's go ahead and export a test user, which will be of type create user input from our create user input DTO, which we know will take an email. So we can call it test@example.com, and our password can just be password. So now we're exporting this test user. Let's go ahead and actually insert it into our database using the user service. So finally, after we have inserted the user, we can just simply close our Nest.js application and let the integration tests continue running. So we've gone ahead and done some setup work every time the tests run. Let's go ahead and do some teardown work so that once the tests finish, we always do some teardown work. So we'll create a new teardown.ts file, and let's go ahead and just copy our setup function in here. So we're going to go ahead and do the same thing where we create our Nest application, but now what we want to do, instead of the user service here, we want to get access to the database service. So we can go to our integration test manager, and we can copy this bit here that we used to get the database service. And so we'll paste this in here, and we'll just import the database service and make sure we set this equal to database service. And so now what we can do is call await database service.getDB handle, and then we're just going to drop the entire database so that every time the tests finish, we remove all data and drop the database completely. We can go ahead and remove these unused imports. And now we have two setup and teardown files that will run every time our tests are run. We need to tell Jest about them. So let's go into our package.json and scroll down until we find a Jest section here. Now in this Jest section, you can specify two properties, global setup. And so global setup will be the path to the setup function that you want to execute. In our case, we know the root directory is already in the source directory, and so we just need to point it to the /test folder and then setup.ts. And now our tests will run this function every time that they are run, and we can provide the global teardown property as well. And we're going to do the same thing except point this to teardown.ts. So now our tests will create a dummy user that we can use for authentication and remove all data after the tests are complete. Let's go ahead and back in our integration test manager, let's actually get the user ID of the test user that is inserted into Mongo. We'll call await this.connection.collection, get the user's collection, and we're going to call find one so that we can get the test user, and we need to import this from the stubs directory, test user.email. So we have this test user, and now what we need to do is actually get the access token for this specific user, because we want to use this later in our integration tests to get past authenticated routes. So let's create a new private variable here called access token of type string. Then we will set this .access token equal to await authService.login. And so authService.login is going to take the user, the test user that is. We can provide all of the properties from it, but we also need to provide the _ID from Mongo. And we can do this by using the user ID we have, pass in the .id, and call toHex string to pass it in as a string. So now every time our tests run in this before all block, we will have an access token to use for our authenticated GraphQL endpoints. So let's go ahead and add a bit more functionality to our integration test manager. We're going to add an after all function that we can call, and all this is going to do is just close our application, and then we'll create two more functions. One called getCollection that will take in the collection name and return this .connection, .collection, and pass in the collection name, so that if our tests need access to a database collection to insert or remove data, they can call this function. Lastly, let's create a getAccessToken function that we can use to return this .accessToken back to our integration tests when they need it. So now that we have this integration test manager, let's actually use it in our create user integration test. We're going to go ahead and create a new const here and call it integration test manager. And it's going to be equal to new integration test manager. And so now that we have the test manager, we can execute a before all block in this test. It's going to be asynchronous. And all we have to do now for every integration test we have is call await integration test manager before all. And all of our setup work will be encapsulated in this one class. Similarly, we can call after all. This will be async, and we do the same thing. We will simply call integration test manager after all. And so now we have all of our setup and cleanup work neatly encapsulated away, and we can begin writing our tests. So before we start actually writing integration tests, we need to install two dependencies that are going to help us do this. So open up a new terminal in this project. I'm going to run pm install GraphQL tag and supertest GraphQL. And make sure we spell GraphQL tag correctly here. So GraphQL tag is going to let us write GraphQL syntax in our code and allow that to be parsed into valid GraphQL language. Supertest GraphQL is a package that will allow us to quickly and easily integrate Supertest with GraphQL, and it will make writing integration tests much easier. So now that we have these two dependencies, we can go ahead and start testing our create user resolver. So if you've seen my other videos on testing, you know I'm a fan of writing tests in a given, when, then set of cases. So we first start off by describing the conditions for a test. So we're going to say that given that the user does not already exist in our system. So when the user does not already exist in our system, there's no setup work for us to do. So we can simply move on to the next when block that says when a create user mutation is executed, we want to test some functionality. So we want to get access to the created user that we're about to create. So let's create a variable here, and we will import the user from the user models directory. And now we're going to have a before all block that'll be asynchronous, because we're going to do some actual asynchronous work here and reach out to our GraphQL server. So in this block, we are actually going to get the response. And this is going to be the response from our GraphQL server. So we're going to call await request. And we're going to actually import request here all the way up top from, so import request from supertest GraphQL. And so request here is a wrapper, a GraphQL wrapper around supertest that will allow us to pass in our HTTP server and execute GraphQL queries. So let's go ahead and specify here a generic type that we're supposed to get back. We know our server is going to return create user, which is of type user. And we know this because if we actually go to the user's resolver, we can see that the type here for create user will be by default create user. So GraphQL will wrap that. And now we need to pass in the HTTP server. Now, if you remember, our integration test manager actually has this as a public property, so we can simply pass this in. And now we can actually call mutate on this. So supertest GraphQL exposes these functions to allow us to execute queries, mutations, and pass variables. So let's execute a mutation here. And now within mutate, we are going to call GQL. And this is from GraphQL tag. So I'm going to call GQL and then open up a pair of template literals here. And now inside of this block, we are actually going to write the mutation that we are wanting to execute. So I'll call this create user. And if we look at our user's resolver, we know that this create user mutation is going to take create user input called create user data. And this will be the email and password of the user that we're trying to create. So we'll go ahead in here and pass a create user data variable that will be of type create user input, and this will be required. So inside, we'll actually execute the create user mutation. We will pass in create user data from our variable create user data. And now we can specify the properties we want to pull back. In this case, we only want to pull back the email from the user. So now we have this mutation. We need to actually supply it with data, the create user data. So we can call .variables here and then specify the data we want to pass with this mutation. In our case, we know it's going to be an object that has a create user data property here, because that is the type in our user's resolver that it expects. So we have that same property here. And with inside of that, we of course need to specify an email and password. Now we could go ahead and hard code an email. However, I want to use stub data that can be shared across multiple tests or in the same test, so we don't have to keep repeating our dummy data, and we can change it out easily. So we already have this sort of in our stubs directory. We have a user stub. However, this isn't really a user stub. It's more of a test user we use for authentication purposes. So let's go ahead and also export another const here called user stub of type user, which will be an object. And of course, we need to specify the ID here, and also go ahead and make sure you actually import the user from the models directory. So for the underscore ID, we're going to generate a new object ID from Mongoose. So I'll call types.objectID.toHex string. This will return a new hex string of this underscore ID, and we import it from Mongoose up here. And then I'm going to specify that email that we want to use for this user. I'll just call it user@example.com. So now that we have this user stub, let's go back to our variables section here in our test, and we will specify that the email should be the user stub.email. And the password here can be a hard-coded string. This is because we only want to use this password one time. This isn't a property that we reuse in tests like the email. So finally, we can actually attach one more jest assertion that says expect no errors, which if we look says that assert that there are no errors in response returned from the GraphQL API. So by default, supertest GraphQL will make sure that we have no errors from this GraphQL request, and it does complete successfully. So that's great, and we can go ahead and set the created user to the response.data.create user here. So now we have the created user, and we know that this mutation executes successfully, otherwise the test will fail. Now we want to actually make an assertion. So let's go ahead and do that in our then clause. So we're going to go ahead and write a test block here that says, then the response should be the newly created user. And inside this test block, all we're going to do is say we call expect the created user from our GraphQL response to match object. And to match object will simply check that a JavaScript object matches a subset of the properties you give it. So in our case, we just want to check that the email matches our user stub.email because this was the email we gave to our server, so we expect the user to have that email. So if this test passes, we know we are looking good. And lastly, we want to check that the user is actually inside of the database. So we can create a new test block here. You want to create a new test block for each assertion you make to keep things nice and organized. So I will say then the new user should be created. This will be an async block, and inside of this test block, let's get access to this user. So we'll create a new const here called user, and then we can use the integration test manager .get collection function and pass in the user's collection. Here we'll call find one and look up this created user by the user stub.email. So this user should exist, and we can assert that by calling expect user to be defined here. So this user needs to be in the database. If it is, our test passes. So now we're ready to actually execute these tests. Let's go ahead and open up our terminal, and we can run pm test. Now, if you're running MongoDB locally, make sure your Mongo server has started up. And once you do so, and you run these tests, you can see that all of them are currently passing. So you can see our test summary here for our create user.integration spec. For our create user tests, we can see our given, when, then block, and you can see how this keeps your tests really nice and organized. So we have given that the user does not already exist. When the mutation is executed, we should see the response should be the expected format and the user should exist. So our test passes and our integration test manager is working properly, as well as our test setup. So now that we've tested a positive case, let's go ahead and test what happens when the user we're trying to create already exists. We know in our application, if we go into our user service, that when we call create user, we actually validate the user data. And if the user already exists by that email, we throw an exception, as you can see here, and validate create user data. So let's go ahead and actually test this functionality out in our integration test. I'll go back into my integration test, and we can open up a new block here, a new describe block. So inside of this given clause, we will say now, given that the user does already exist. So normally this is when you would do some setup work for all of the tests that have to meet this condition. So we would do a before all block and insert a test user. However, our setup work is already doing this. We are already inserting our test user as we have done in our setup.ts. We're already inserting a test user, so we don't need to really do this again. Let's take advantage of this by immediately going to the when block and saying when a create user mutation is executed. So when this mutation is executed, we want to get access to the status. So we'll call a new variable here called red status of type number. And we want to make sure this status is equal to an unprocessable entity, which is a 422. So let's go ahead and actually execute our request. We'll have a new before all block here, which will be asynchronous. So I'm going to create a new destructured object here. And notice I'm pulling the response out of this object here, which is going to be equal to await request. And now we are getting back same response, expected a create user object here. And we're going to pass in the integration test manager.http server as we have done before. So now we're ready to make our request. We can actually copy all of the request code we've already created up here. We don't want to copy over the expect no errors from this because we actually do expect errors to be coming back from this call. We're going to paste this in here, and I'm actually going to wrap response in an object here so that we destructure it. And next, I want to set my create user data equal to exactly the test user in our system. This user already exists, so we want to trigger that unprocessable entity. So now that we're sending this response off, we want to actually get the status code from the GraphQL response. And in order to do this, let's create a common function in our test folder, our root test folder called gqlstatus.ts, because we're going to have to do this more than once. So we'll go ahead and export a common function called getGQLErrorStatus, which will take in the response from request.response, and I will import request here from supertest. We're going to return a number, And so we'll open up a function body here, and we're going to return the response.body.errors. The first error we receive, we will pull the extensions off of it and then get the code. So this will give us the error code of the first error thrown from our Nest.js server. So now that we have that status code, let's actually get it. We will set res status equal to get GQL error status, and we'll pass in the response here. So now that we actually have the status, we're going to go ahead and write an assertion. So let's write our test block that says, then the response should be a 422. And we can go ahead and test this by calling expect res status to be 422, and this will be a string value. So let's go ahead and test this out. We'll open our terminal back up, and we can run pnpm test. So you can see our tests are passing because the user already exists. We're getting a 422 error code from the server. So now that we've tested the create user mutation, let's go ahead and test getting a user from our server. And of course, this is actually protected by our JWT cookie guard here. So we're going to need a way to actually authenticate ourselves in Supertest. Let's go ahead and start off by creating a new test in our integration folder called getuser.integration.spec.ts. So I'll open up a describe block here and call it getUser because that is the endpoint we're testing. And we're going to go ahead and of course start off by creating a new integration test manager. And then we're going to execute our before all and after all blocks. We can simply go into our existing create user test and copy this in here so that we are running our before all and after all hooks to set up our application. Let's go ahead and create a new describe block. And we're going to start off by saying, given that the user does already exist, as we've done in our previous tests. So given that the user does already exist, we already know that the test user does exist in our system. However, we need to get the actual ID of that user after it's been inserted into the database. So let's do that in our setup block here. We'll create a new variable called user ID, and we will get this in a before all block. So we'll make this asynchronous, and we'll set the user ID equal to await integration test manager dot get collection. This will be the user's collection, and we'll call find one, where we are looking for the user with the test user.email that we inserted at the beginning of our test. So after we have that user, we'll get the underscore ID and call 2-hex string. So we get the user ID string here, and make sure you've spelled async correctly, as I have not done here. So now we have the user ID. We can go ahead and open up a when block that says when a get user query is executed. And of course, we will actually do this. We will get access to the user that we're trying to query. So we'll give it a type user here. And then we're going to have a before all block where we actually execute our query. So let's open up an async block, and as we've done before, we'll pull back the response by calling await request. And make sure you import request. You might have to do this manually up top, but make sure you import request from Supertest GraphQL. And the object that we're expecting back in the user's resolver is of type user. So that's what our object will look like. So let's open up an object here and give us some type inference. It'll look like a user. And so we can pass in the integration test manager.http server as we've done before in our other tests. And now in order to actually set authentication credentials for our server, we're going to call .set, which will allow us to set any header we want. In this case, we want to actually set a cookie. So let's go ahead and call set cookie, and we'll open up a template literal because we want this cookie to read authentication equal, and then we're going to call integration test manager dot get access token. So for this request, we are setting that authentication cookie using our integration test manager so that our GraphQL server passes authentication and knows who we are. And then we can call .query, and as we've done before, we will call GQL inside, open up a template literal, and write our query here called getUser. This will take the underscore ID of type string, and we can confirm this by going to our user's resolver and looking at the getUser args. we can see of type _ID. So we need to provide this in this query. We'll open it up and provide the user query itself by passing in the _ID. Now that we have the user back, we will pull the email off of the user. And then lastly, we'll specify the dot variables where we actually provide the _ID. And of course, this is where we can pass in the user ID that we extracted at the test setup, where we actually found the user in the database. So we'll set the user we got back equal to response.data.user. And now that we have the user back, we will make an assertion here and say that the response, then the response should be the user. And we can do a simple assertion by saying expect the user to equal an object that has the email of the test user that we know exists in the database. So if the user we got back is the user we found at the beginning of the test, we are successful. Let's go ahead and run this by running pm test. And you'll notice that I'm constantly running the tests while I'm writing them, which is a great way to make sure that you're actually making meaningful progress in your tests. So you can see our tests have all passed here. So this has been how to write integration tests in Nest.js for a GraphQL server. I hope this technique and pattern has been helpful for you. If you have any questions, feel free to leave them in the comments, and I'll see you in the next one.